Here's the first of our right triangle problems. This is problem number 1 from part 2 of your review sheet. The problem said, find the length of the hypotenuse. Remember, the hypotenuse is the longest side of a right triangle. It's the side opposite the right angle. Find the length of the hypotenuse of a right triangle if the lengths of the other two sides are 4 and 8. It said, express your answer in simplified radical form and round it to the nearest tenth. Remember, a Greek mathematician by the name of Pythagoras many years ago discovered a relationship, or at least he's credited with having discovered a relationship, between the lengths of the sides of a right triangle. For any right triangle, c squared, which is always associated with the hypotenuse. The C letter is always associated with the side opposite the right angle, the hypotenuse. C squared equals A squared plus B squared. So we can determine the length of any side if we know the lengths of the other two sides. So in this case, the side we are missing is the C side. So we can plug those values into that formula. So we'd have C squared equals 4 squared plus 8 squared. So C squared equals 4 squared is 16 plus 8 squared is 64. So C squared equals 80, and C equals the square root of 80. So we can now take our calculator, use the square root function to find the square root of 80. And in this particular instance, that is not a whole number. 80 is not one of our perfect square numbers, so there's no whole number you can square that makes 80. The square root of 80 comes out to be then 8.9. Almost 9, because 9 squared would be 81, wouldn't it? So it's got to be very close to 9, and indeed it was. So the square root here, rounded to the nearest tenth, is 8.9. So the length of this side of the right triangle would be approximately 8.9 units. And we use the theorem of Pythagoras, c squared equals a squared plus b squared, to determine that measurement.